So here this is my second question from latent heat. If you want to understand the concept of latent heat, how to do these sums, please see my previous video. Check the videos in calorimetry playlist. You'll get them all there. So we are doing sums from concise physics. Okay, a refrigerator converts 100 grams of water at 20 degree to ice at minus 10 degree. So refrigerator converts 100 grams, mass is 100 grams. Now you should make a note of that immediately. Okay, 100 grams of water at 20 degree. At 20 degree you have this water, and which is becoming minus, so again you get 100 grams of ice at minus 10 degrees centigrade. Calculate the average rate of heat extraction in watts. Okay, calculate the average rate of, and they have given all the values. They have specific heat capacity of water, specific latent heat is given, and specific heat capacity of, okay, so specific heat capacity of water 4.2 is given, specific latent heat of ice is also given, and specific heat capacity of ice is also given. Now the moment you start with these questions, check one thing, otherwise you might go wrong. The moment I am seeing these grams here, everything, all the units have gram, then I am seeing this, is this also in gram or is it in kg? So that should match first. Okay, now I am going to convert this water which is at 100 degree. So first at 20 degree it has to come from 100 degree, it has to come from 20 degrees centigrade, it has to come to 0 degree. But then again from 0 degree it has to come to minus 10 degree. How to do this? Now here we will be using MC theta. This is what I have told to check in the previous video, and here we will be using ml, and here again MC theta. Now here mass of ice, specific heat capacity of water will be used here, because between 20 and 0 degree it is water only, and theta is the difference in temperature. ml is here mass of water into latent heat of ice. Okay, or they sometimes write it as latent heat of fusion also. And here mass of water, again the mass is going to remain straight, same anyway. Specific heat capacity of ice, which is this, will be specific heat capacity of ice, sorry, this is 2.1, by mistake I wrote. So specific heat capacity of ice will be used here, and theta, which is the difference in temperature. Okay, so here how much heat lost, what is the heat lost? Because we have put it in a refrigerator, it has to lose heat. So first it is MC theta, where M is 100, C is a 4.2 for water, and theta is a 20. Okay, plus again 100 into 336, and plus it is 100 into 2.1 into, comes to 0 to minus 10, difference in temperature is a 10. So how much do I get? I get a this one. Okay, if I multiply this, I'll get this. Okay, on adding, how much am I getting? So if I multiply this, I get 44100. This much I get on multiplying. That is 44,000. Here it's already 33,000. So it comes to 44,100 joules. This much of heat it has to lose to come to ice at minus 10. Now, what should be the capacity of the refrigerator? Okay, calculate the average rate of heat extraction, means they are basically asking for the power of the refrigerator. Now for power formula, you know, power is written here, energy, it can be heat energy, it can be electrical energy, it can be any energy, it can be work done by time. Here this power, if it is in watts, okay, supposing this power is in watts, this energy has to be in joules, time has to be in seconds. This is coming from the formula of power. It applies for your mechanics, it applies for your electricity, it applies for your heat also. Okay, now if I want to find the rate of heat extraction, let me first see how much of heat is being extracted per minute, because they have given us in minute. So rate of heat extraction 44100, that has been extracted in 73.5 minutes. If you shift the decimal here, okay, you will be able to get 600. If you do this calculation, you will get 600. Okay, 600 what? It comes to 600 joules per minute. Okay, let's go back to the formula of power, which says they want the heat in joules but they want the time in seconds. Okay, so what we will do? We will say power is equal to 600 by, this is per minute, let me divide it by 60. Okay, because I want it, because this was happening per minute, I'll divide it by 60 to get per second, which comes to a 10. I must write watts, because when this is in joules, this is in seconds, this comes in watts. Okay, here you should write rate, don't write power here. If you write power here, you can't use this unit. So you have to be very, very careful about these things. Okay, so this was my second question from calorimetry, second part. Okay, so you'll see that in the chapter calorimetry there are two parts. The second part is latent heat. The first part is specific heat. So I have different videos for specific heat sums. So here latent heat, this is the second part, and you will get it in the playlist. Wherever you see latent heat questions, you check for part 1, part 2, you'll get all the sums in line. So I am doing all important sums from Concise Physics. Okay, so check my next video after this for more sums. If you have not subscribed, please subscribe, because I shall be uploading lots of questions like this, one after the other, in maths and physics till you write your ICSE. Okay, thanks all of you. Bye then.